Hi everyone, let's continue. So last two videos we talk about how to set up triple integrals with cylindrical coordinates and spherical coordinates. We also talk about the relationship between among those three coordinate systems: rectangular coordinates, also called Cartesian coordinates, and cylindrical coordinates and spherical coordinates. So when do we use cylindrical coordinates? When it's like a circular cylinder, okay? So the intersection is maybe we have some intersection, we have some surface, and the intersection, when we project down to the xy plane, we get a disk. Okay, then we can think about cylindrical coordinates. And when do we use spherical coordinates? When one of the surface is like a sphere. Okay, so but for some solids, integrating in the standard order dz, dr, d theta is not the best, because it may be much easier to describe r in terms of z than it is to describe z in terms of r. Okay, so let me review with you. So for rectangular coordinates, dv is dx, dy, dz, and it could be other order as well, right? We know there are 6 different order. dy, dz, dx. Let me erase this. And it could be dz, dx, dy. It could be dz, dy, dx. Okay, 6 different order for rectangular coordinates. And then for cylindrical coordinates and dv equals to r dz, dr, d theta. And we can sometimes, if the surface we express r in terms of z and theta, it's better to use the order dr, dz, d theta. Okay, there could be some other order as well, but mainly we use these two. Okay, so how about spherical coordinates? We have dv equals rho squared sine phi d rho d phi d theta, and it could be other order as well, but usually for our surface, rho is a function of phi and theta, so this is the natural order. Okay, all right, but depends on the problem, we might have another order as well. Okay, so let's look at the following example. Find the volume of the solid that is described by the following inequalities. So x squared plus y squared square root less than equal to 2 minus cosine z. Well, if you think of cylindrical coordinates, well, this guy looks like r, right? So r less than equal to 2 minus cosine z. Okay, so what is r equals 2 minus cosine z? Well, if we look at if we look at this solid, okay, this is it. Okay, so this curve is 2 minus cosine z. So far so good, everybody. Okay, and you can see r is a function of z. So when we set up the volume, we have 1 and then r, because r is a function of z, so we want to have dr, dz, d theta. So far so good. And then from the outside to the inside, theta is still from 0 to 2 pi. Now how about the z? You see z is from minus pi to pi. Now how about r? R is from 0 to this surface to minus cosine z. So this is how we set up the integral. So far so good. And then we can continue to solve the integral. So the integral of r with respect to r is r squared over 2. And then we evaluate from 0 to 2 minus cosine z. And then we have d z d theta. Okay, what is that? Well, we can put the half in front, right? So we can put the half in front. And then, we plug in 2 minus cosine z squared minus 0 squared is 0. Okay, so we have this guy and dz d theta. And we don't have like product rule or power rule for, this guy, okay, this is like products. We don't have product rule for integral. So what we should do is we should multiply it out. So when we multiply it out, we have, oh, by the way, can you see this guy is symmetry about okay, so let's see, here we have z, here we have the r, and do you know what is 2 minus cosine z? So cosine z looks like this, right? 2 minus that, so at 0, 2 minus 1 is 1, and then at pi over 2, we get 0. 2 minus 0 is 2. Okay, and at pi, we have minus 1. 2 minus negative 1 becomes 2 plus 1. This is 3. So you can see, okay. So this is r equals 2 minus cosine z. And you can see this is symmetry. So this region and this region, they're the same. So it is the same as, okay, it is the same as we calculated from 0 to pi and then multiply by 2. But because we have 1/2, it's cancelled. Is that okay, everybody? You can see this top one and the bottom one, they're the symmetry. They're the same. Okay, same. They have the same volume. So, I really love the 0 because when we plug in 0, it's much nice. And then let's distribute this. Multiply out. So when we expand it, this is 4 minus 4 cosine z plus cosine z squared dz d theta. Okay, so how do we integrate that? So that equals 0 to 2 pi. Okay, so here we're using the double angle formula. Okay, we know how to integrate 4. We know how to integrate 4 cosine z, but for cosine squared, we gotta use the double angle formula. Do you remember what it is? 1/2 plus 1/2 2z. Okay. So this 1/2 and the 4, we can combine them. We get 4 plus 1/2 is 9/2. And we have minus 4 cosine z. And then plus 1/2 cosine 2z. dz d theta. Okay, let's integrate. So we have 9 over 2z minus integral of cosine z is negative. It's positive sine z. So 4 sine z. Okay, integral cosine is sine 2z and then divided by 2 because of the chain rule. Z from 0 to pi d theta. Okay, now let's see. We have 9 over 2, and then we have pi minus 0. So 0 is gone. And then 4 sine pi minus sine 0. You know sine pi is 0, sine of 0 is 0. So this term is gone. And then, oops. And then we have 1 over 4 sine, 2 pi minus sine of 0. And they're all 0. So this guy is also gone. So we only left with 9 over 2 pi, and then when we integrate the constant, we get theta. Theta is from 0 to 2 pi, so the answer is 9 over 2 pi times 2 pi. 2 cancel, we have 9 pi squared. So far so good, everybody. Okay, so this is the volume of this solid. Yeah, so sometimes we may change the order, depends on the surface. Okay. Let's continue. So consider the following integral. Sketch the solids of integration and rewrite the integral in all possible orders. So we have 6 ways different. This is just one way, right? Okay, let's see. So we read from the outside to the inside. So x, y, z. dx, so x is from 0 to 1. Okay, everybody? 0 to 1. So dx, so that's the width, dx. Okay. And then next we have dy, so we draw a rectangle on the xy plane, and y is from minus 1. Oh, so here, minus 1 to 0. Oh, so we just get, this is a little rectangle. And you can see the base region, this is the base region. And then on any point on this, pick a point on this rectangle, and we go to the z direction, and z is from 0 to y squared. What is z equals y squared? Well, this is a parabola, right? So let's see, this is a parabola, and it looks like that. Can you imagine this is a parabola? So my z is from, oh, let me draw it better. Okay, somewhere here. Okay, from 0 to, this is z equals y squared. Okay, and what is the solid? Well, the solid is this guy. Okay. Yes, this is the solid. Can you imagine, everybody? Okay, so we want to rewrite this integral in all other possible orders. Okay, now let's see. Let me draw this guy again. Okay. Okay, so let's use this order. So this is dy. Okay. So x squared stay inside. And here we have dz, dx, dy. So y is from -1 to 0. And x from 0 to 1. And z, any point on this rectangle, z is from 0 to z equals y squared. So this is how we set it up. So far so good, everybody. Okay, then let's continue. Let me use a different color. How about purple? Okay. So let me draw this guy again. Oops. Okay, so okay. So let's change the order. Let's say d x d y d z. Okay, what does that mean? Well, first look at dz. Okay, now z is between two numbers, so this is 0. What is this number? Okay, this number because y is equals to z equals to y squared. When y is minus 1, z is also equals to 1. Okay, so we know this is 1. So z is from 0 to 1. And then y, well, how about the y? See, then we draw this rectangle. Oh, not here. The y is here. So on the YZ plane. So this is the little rectangle. Can you imagine, everybody? Let me draw the DZ here so it won't block the rectangle. So this is a rectangle, and y is from 0 to, okay, this is on the parabola, but we need to solve for y. So y equals, and because y is negative, sorry, the 0 is here. Okay, so yeah. So y is negative, and this negative square root of z. So y is from from minus 1 to negative square root of z. Sorry, this is not 0. This is y equals negative 1. So far so good, everybody. So this is the z, this is the y, and then how about the x? Well, any points on here, you look at the x, well, the x is also from 0 to 1. So far so good, everybody. Okay, let's continue. What happens if we have x squared x squared dx d z dy? Wow. Okay. Let me draw another picture here. Okay, so dy is here, and then y is from minus 1 to 0, and then z, so we want to draw a rectangle on the yz plane. Z is from 0 to this parabola, which is y squared. Okay, and then any point on here, draw in the x direction, so you can see x is still from 0 to 1. So far so good, everybody. Okay, and then we still need 2 other ways. Okay, 2, yeah, with 6 total, right? And the problem we're having the one of them, so we need to find the other 5. And let's see, we have the z and dx. Next is gonna be dy. Go first. So let's see what color we haven't used. Okay, so let's pick a different color. So let's draw the picture again. Okay, so we want to have x squared, and we want to have dy go first. So let's see. Okay, so this guy, dz is right here. And then dx, so you want to draw this on the xz plane. Okay, so you can see, so this is 0, and the z goes from 0 to 1, and then our x goes from 0 to 1 as well. And then on the rectangle, okay, we can see this point corresponds to y equals -1. This point corresponds on the parabola, right? And we need to solve for y, but because y is negative, we have y equals minus square root of z. So we have -1 square root negative square root of z. So far, so good, everybody. Okay, let's continue. Let's see. Here we have x squared dy dz dx, and we can see from the picture where is dx. So this is dx. Okay, and then dz. So we want to draw a rectangle on the xz plane parallel to the z-axis. So x is from 0 to 1, z is also from 0 to 1 because this guy is a rectangle. Okay, and then on the point and on this rectangle, so we go in the y direction. So we have y goes from -1 to this point is still negative square root of z. So far, so good, everybody. Now we have finished the 5 other ways of writing this triple integrals. Okay. Do you want to solve this triple integrals? Yes. Okay, let me copy the function, and then we can try to solve it. And just to do more exercise. Okay. So that equals -1, 0 to 1, and -1 to 0. Okay, first we integrate with respect to z. So x squared z. Z is from 0 to y squared. And then dy dx. And then we plug in z equals y squared minus we plug in z equals 0, but that's 0. So we have dy dx. Okay, so we integrate with respect to y. We have x squared y cubed over 3. Evaluate from -1 to 0 dx. Okay, so we plug in 0 first, minus we plug in -1. So that would give us -1 over 3, right? So that is 1/3. Okay, so we can pull out the 1/3, and then we have integral of x squared. Integral of x squared, we have x cubed over 3. Evaluate from 0 to 1. So we plug in 1 first, minus we plug in 0. Oh, so the answer is 1/9. So far, so good. So the volume of this solid equals 1/9. Okay, so that is session 13.5. So I hope you can do more exercise. Like beside your homework, you can find some problems from your textbook to practice. And also practice, try to set up the triple integrals in different order. Okay, so yes, that's better because when you practice writing the triple integral in different order, then you can compare different order, and then you can compare the integrals, which one is easier to compute, and then you kind of know the advantage or disadvantage between different order or different coordinate systems. Okay, so have more practice. Now we have learned triple integral in 3 different coordinate systems, and we also learned with coordinate system how to set up in different orders. Okay, so get more practice. If you have some questions, please feel free to print screen and then ask me either in class or in office hours, or send me an email. Have a nice day. Bye.